Every request that hits your AI app has to go somewhere. Which model, which tool, which prompt template? The lazy fix is to ask a big language model to decide, but that costs a full call just to answer where should this go. A semantic router skips all of that. It reads the meaning of a request and dispatches it in milliseconds. Today, we're breaking down how it works, why teams reach for it, and where it falls short. To see why this is fast, follow one request as it travels through the router. It starts with the incoming query, plain text from a user. At this point, the router knows nothing about intent. It just has words on the way in, waiting to be understood. First, the router embeds that query into a vector, turning the sentence into a point in meaning space. Similar phrasings land near each other, which is the whole trick that makes the next step possible. Then it compares that vector against pre-computed centroids, one per route, each built from a handful of reference utterances you supplied ahead of time. Cosine similarity picks the nearest route. No language model is called, so the decision is fast, cheap, and deterministic, and because the centroids are computed once and reused, routing at request time is little more than a distance calculation. Finally, the request is dispatched to whatever that route points at. A small cheat model for easy questions, a frontier model for hard ones, a specific tool, or a tailored prompt template. Now, why do teams keep reaching for this pattern? 3 payoffs stand out. Embed and match. The router turns each request into a vector and finds the nearest reference route. Its classification by similarity. No prompt engineering and no generation involved at all. No language model call. Because the decision is pure embedding math, it's fast, cheap, and deterministic. The same input always routes the same way, which makes behavior easy to test and reason about. Model tiering by cost. Send easy queries to a small cheat model and reserve the expensive frontier model for the hard ones. You can also gate tools, block off topic input before it ever reaches a model, or pick the right prompt template for the job, all from the same instant embedding match. It's clearest when you put beside the obvious alternative. Using a language model as the router is flexible. It understands nuance and novel phrasing. But every routing decision costs a full model call, adding latency and expense, and the answer can drift from one run to the next. A semantic router trades that flexibility for speed. An instant embedding match, deterministic and nearly free, with no full model call and hot path. The catch is that it needs good reference utterances and genuinely novel phrasings. Far from anything you supplied can trip it up and land in the wrong route. The Aurelio semantic router library popularized this approach, and many teams pair it with a language model fallback for the odd request that doesn't cleanly match. Okay, for things to lock in. A semantic router picks a model, tool, or prompt by embedding the query and matching the nearest reference route. Because it uses no language model call, routing is fast, cheap, and deterministic. The same input always goes the same place. It shines at cost-based tiering. Cheap model for easy queries, frontier model for hard ones, plus tool gating. The catch is that it leans on good reference utterances and can miss on genuinely novel phrasing. If breaking down AI like this is your thing, Standarity.com has a whole shelf of them waiting. See you in the next one.